Hello, we're working on this video in chapter 1 section 4. We're going to do the other skill. We're only doing 2 skills from each of these sections 3, 4, and 5. The other ones you can read about them, that's fine, but this is what we need you to know for the other concepts we're going to be learning later this year. In this one, we're going to be talking about simplifying algebraic expressions. And I'm almost certain that you've heard the phrase combine like terms or add like terms. And then someone says, well, what is a like term? What do you mean by like terms? And then probably the teacher gave you a complicated answer. Like terms have the same variable raised to the same exponent. And then you're like, that sounds great. Okay, I can do that. And the biggest problem is don't add terms if they are not like terms. We always get into wanting to go a little bit further beyond what you can do. So as you probably, if you're watching the videos in order, you probably have heard me kind of rant a little bit about the fact that I really want you to understand why things are happening, not just how things are happening. So I'm going to try to explain simplifying with like terms by going back to what you already know, okay? So what if we were to consider this problem? 742 plus 235. So it's all right, I want you to add that. Now, some of you are going to be able to add it in your head. What you do when you add it in your head is probably what the other people are going to do when they write it down. They're going to write it vertically. So whether you think you write it, most people are going to do this. They're going to do 742 plus 235. And then you add the 2 and the 5, add the 4 and the 3, add the 7 and the 2, and you get 977. Okay, you're probably thinking, why am I watching this high school Algebra 2 accelerated class just to do some adding like that? Well, the question is, why did you add it this way? Why didn't you do this? 742 and 235 like that. And get what? 7655. And you're probably thinking, well, why would you do that? That doesn't make sense. Well, okay, well, why do you do it this way and not this way? You say, well, because you want the things to line up. Well, what does that mean? What if I did this problem? 742.6 plus 235.94. I want things to line up, right? So you do 742.6, and then I do 235.94. Nice edge over here. Everything's lined up. Now you're probably thinking to yourself, but it's not lined up. Well, this looks like this over here. I got the 6 right above the 4. I don't have any gaps like I had here. And of course, you're probably screaming into your iPad right now, you got to line up the decimal point. All right? So the question is, why? The decimal point was hidden over here. Over here, now the decimal points aren't lined up. And if we go back to elementary school, you will see elementary school teachers in the 2nd or 3rd grade, I don't know when you do triple digit adding, but you will see them trying to explain how to line stuff up. And when you throw in decimals, what you learned over here gets thrown out. It confuses people. Okay, so I'm gonna try to break this down so you guys understand what's really happening. How do I know to add the 7 to the 2? Here's the key. That's not a 7. Go ahead, pause it, walk away, come back, and say, my math teacher just looked at that and said, that's not a 7. That's not a 7. It's 700. That's not a 2. It's 200. Because this number right here, 742, is actually 700 plus 40 plus 2. 235 is 200 plus 30 plus 5. These are the hundreds, these are the tens, and these are the ones. We're talking place value. And when we talk about place value, that's where the decimal comes in. Because I want, this doesn't work because this is the 10th right here. That is the 10th spot with a TH. And it's not lined up with the 9 that's in the same position, same place value. Okay, so I add using place value. But what actually does place value mean? Well, let's break this down even further. This is 7 times 100. Get it? Hundreds. This is 4 times 10. And this is 2 times 1. The next one is 2 times 100 plus 3 times 10 plus 5 times 1. Okay, you're probably looking at that going, why would I do that? Again, I'm not using this to find the answer. I already know the answer is 977. I'm using it to explain a more complicated idea. This tells me what the place values is, but I already said it was 100, 10s, and 1s. But there's even a better way of writing this. This is 7 times 10 to the second power plus 4 times 10 to the first power plus 2 times 10 to, believe it or not, the 0 power. We'll talk about that later. That's actually in the next videos. The other one, 235, is 2 times 10 to the second power plus 3 times 10 to the first power plus 5 times 10 to the 0 power. You can only add like terms. And like terms have the same variable, but in this case, it's not a variable, to the same exponents. So I can only add 7 of the 10 squares plus 2 more of the 10 squares, which gives me 9 times 10 to the second power. I've got 4 of the 10 to the first power. I've got 3 of 10 to the first power. So I've got 7 10 to the first powers. And of course, I've got 7 10 to the 0 power. And that's going to give me my 977, which is what I said it was. Now, right now, we're a couple minutes into the video, and you're wondering, what does this have to do with the algebraic expressions? Because if you understand this problem, then this problem, I'm going to scoot up a little bit so you can see it. If you understand how this means that, then you will be able to do this problem. I can only add these two to each other. I can only add these two to each other. I can only add these two to each other. That's the same as that, except instead of 10, with a base of 10, I'm using a base of x. By the way, what do I mean base of 10? Why do I use 10 here? Why do I go 10, hundreds, 10, or sorry, thousands, 10 thousandths? Right there. That's how humans count. 10 fingers, 10 digits. So our numbering system, and I apologize because I said humans, not every culture uses base 10. You know, if we were doing this with Roman numerals, it'd be a whole different conversation. All right? And there are other cultures that have historically used other bases because they didn't use their fingers when they first learned to count. They used other things. Okay? But for our Arabic numeral system, which is actually based on Hindu numeric systems, which we can look that up and discuss later, we use 10 symbols. Like whatever number that you have, we only have 10 symbols. If you pull up your keyboard or on your calculator or calculator on your phone, there's only 10 buttons, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all of those are just, all the numbers we have are just using those symbols. So we use a base 10 numbering system, but if you understand that, then I can teach you the algebra that goes behind it. And that's what I mean by like terms. Only add like x squares to x squares, just like I only add 10 squared to 10 squared. Okay. Let's actually do some problems. So look at this. One way of doing it, and most people wouldn't do this. Again, it's the question between understanding what's happening, me teaching it, and versus let's just get the answer. This actually can be written like this. x squared plus 5x. The 2y is going to be in a separate form because it's not the same variable. And then the 7x squared, I'm going to put below here. And that's kind of like saying 0x plus 0y. If I add it all together, I get 8x squared plus 5x plus 2y. Now this is understanding what's happening. If you just come over here and say, that's a like term with that, 8x squared plus 5x plus 2y, because these are not like terms, then you're done. This is just getting the answer. Before we do B, I got to talk about these parentheses. Parentheses mean do this first. Unfortunately, a squared and a are not like terms. They don't have the same place value, so I cannot combine them. I cannot add or subtract, or sorry, subtract but adding the opposite. Okay? That B in front of it actually means distribution, right? So, for example, if I make it a simpler problem, if I said 3 times 1 plus 4, that'd be 3 times 5, which is 15. We got that. Do what's inside the parentheses first. Sorry. But this would be the same as 3 groups of 1 plus 4. So I would have 3 of the 1s plus 3 of the 4s. And 3 plus 12 still equals 15. So if I can add inside the parentheses, go for it. But if I can't, I can use what's called distribution. And I'm going to share that 5 with both of these terms. Sorry, not the 5, I apologize. I'm not going to redo the video just for that mistake. I'm going to share the b with both the terms. So it's b times 5a squared plus b times negative 2a. And then the minus 11a squared plus 2ab are going to come along for the ride. I haven't done anything with them yet. Now let's multiply and simplify all this. This is 5. Usually when I have multiple variables, I put them in alphabetical order. It doesn't change anything. It just makes it better. Sorry about the phone ringing. I'm too far in the video to start over. Plus negative 2 times a times b plus negative 11 times a squared plus 2 times a times b. A squared b, I don't have any other a squared times b. There's an a squared, but I also have to have a squared times b. So that stays the same. Negative 2ab, that's not a like term, but that is. Negative 2 plus positive 2 is 0. So that plus that equals 0. I could add 0. I could put a plus 0. But most of you probably wouldn't do that. But it's still there. It doesn't matter. It's still there. Plus negative 11a squared. In my class, you can always show the hidden things. Okay? All right, I should write you can. The way I wrote it makes it seem like I want you to every time. So in my class, I'm always okay if you show things that are hidden. If you wrote a plus 0, that's communicating to me that you saw that plus that equals 0. So you're telling me something, which is perfectly okay. But if you didn't, you would just end up with this. 5a squared b minus 11a squared. Finally, for the last one, I get negative 3 times 2x, negative 3 times negative xy, negative 3 times 3y, subtract 11xy. So I shared that negative 3 with that, and that. Negative 6x, negative times negative is positive 3xy, negative 9y, negative 11xy. This has an x, that has an x, but it also has a y. Same thing here. So no like terms with the negative 6x. 3xy subtract 11xy is negative 8xy. And the negative 9y just continues along. Okay, so again, one of the things I want you to get out of this is that these problems where some of you, not all of you, but some of you learned just show me how to get the answer, they actually have deeper meanings There's more math involved with them that's going to allow you to have a stronger understanding of what's really happening. Okay? So I don't want you to panic or anything. It'll be okay.